there will be two problems from chapter 10, and that's about the length of the curve, and the curve can be expressed in as using parametric equations. Also can be expressed in polar equations. Okay. So let's see. So the first problem, okay. Find the exact length of the curve. Okay. The curve is given by the equations tx squared over 2 minus half of t. Okay. And the one okay, y is going to be just equal t. Okay, just for example, I'm not going to make a very nice example sketch. Just give an example. So this is kind of type of problems you have to solve. No, it's parametric equations. Okay, so they're given by parameters. So when t equal, you don't need to sketch this graph, not necessary. Okay. So how do you solve the problems like that? Step 1, you write down the integral for the length. Okay. The next step is to try to evaluate if possible. If not, just leave that. But make sure the formula is correct. So the length, that's the first step. The interval t is from 0 to 1, and here and this is a should be formula, right? Then you put in the details. The derivative here is t, right? And the minus half of, yeah. So plus 1 and dt. Maybe you cannot evaluate, then just leave that. I'm not sure. I just randomly pick up two functions, so it's not clear if I'm able to evaluate or not. Okay, so it's the integral. This is a t squared. Okay. Okay. Yeah, I'm trying to make a problem which I can evaluate. So yeah, let me make it. This is a, I put the 4 here and I put an echelon. Okay, then it works. Actually, when you this is half of that. This is a 2t. Okay, so when you square it, you get 4. Then you more product of those two terms. That is going to be 1/2 because 2 twice of t over 2 times 1 over 2t. Okay, it's cancelled out, and then 4t squared, and then here plus 1. Okay, dt. And then you see that negative 1/2 and 1 combined, you will get t squared over 4 plus positive plus 1/2. Then this becomes a square again. Just change the sign from negative to positive. That is going to be 2t here plus 2t squared. Okay. Then this is going to be half of t plus 2 over t dt. Okay. Now this one, if I do not change the interval for this problem, this has infinite length. Okay. The length is infinite. So if I change interval from 1 to 2, then it's a finite because 1 over t, 1 over t, approaches infinity when t approaches 0. Okay, so this has infinite length. The exact values will be, yeah, clearly it's going to be infinity. Okay, if I change the interval like from 1 to 2 or from 1 to 10, and you get a finite number. Okay. So I did not pick up a right function. So this is just give example. The second problem is the curve is given by a polar equation. Find the length of the curve. Okay, this is determined by the polar equation. R equals 2 minus sine theta. Okay, and also trying to find the area enclosed by this. Yeah, then find the area enclosed by this curve. This is a closed curve. Yeah, enclosed by this curve. All right, so you may want to draw the graph, but don't waste too much time to draw the graph. I'm pretty sure I is always positive, so this does not have self-intersection, this curve. So when theta equals 0, I is 2. When theta equals pi, I is going to be 3, so it's -3. So I think the graph looks like that. The question is, do you still remember the formula for the arc length of the curve given by polar equation? Okay, if you don't, then you have to try to set up derive the formula by yourself. Okay, the length, I think it's from 0 to 2 pi because it's complete, right? I think it's r squared plus dr d theta squared d theta. And sine should be wrong. Okay, cosine. Okay. This actually, you get that using the polar, using the parametric equations. Okay, and I is going to be function of theta. Then you differentiate and the square. I think that's what you cosine and sine theta will be canceled out. You end up with that formula. Okay. All right. So I'm not sure I can evaluate. It's not just set up integral. Okay. So R, this is going to be right, and the derivative R is going to be negative cosine theta squared d theta. So that will be 4 minus 4 sine theta, and sine squared theta, cosine squared theta is just 1. So you end up with an integral 5 minus 4 sine theta d theta. I'm not sure we're going to evaluate the integral, this type of integral. Okay. It's not clear. Okay. Maybe you can use a substitution. Okay. Well, one thing you can try is sine theta equals 1 minus, no, it's not double. If you're not able to evaluate this integral, just leave it like that. Okay, make sure all the computation is correct. You're not going to lose too much credit. Okay, so this is the integral of 5 minus 4 sine theta. This is inside the red. Okay, maybe you're not able to evaluate this. Okay, let me think about it because I just randomly picked the problem. This is if we cannot express this as like a square of some function, then we're not able to evaluate this integral. Okay. You may also try other substitutions. Okay. I don't think it works. Okay. Now what you can do is find the area enclosed by this curve. No question. Okay. Find the area enclosed by this curve. then you can always evaluate integral because this is a 2 minus sine theta squared d theta. It does not involve radicals, right? So you can multiply this out to 4 sine theta and plus sine squared theta. Now sine squared theta should be replaced by cosine, right? Cosine 2 theta 1 minus cos, because cosine 2 theta equals 1 minus sine squared theta twice, right? So you move, yes, minus del by 2, right? So for sine squared theta. So what you get here is you get integral sine theta, integral cosine 2 theta, they'll be all gone. And 4 plus 1/2 is on. 4 plus 1/2 is constant, right? 1/2 come from here. So then multiply by 2 pi, right? And the answer would be 9 pi over 2. Okay. This is the area can be evaluated easily. All right, so the rest of the problems from chapter 11. Okay. The rest of the problem from chapter 11. For example, if you are given a series like this is going to be n squared plus n plus 1. Okay. Is this series convergent or divergent? At this point, you should tell me immediately. Why? Okay. Convergent or divergent? How about you? You said divergent.
Divergent.
Divergent? Why?
You could use a comparison test, and for the comparison, you could use n over root n squared, and then that would just be 4.
But this is I don't think comparison test works here because you will be less. This will be less than equal to 1. But does not imply the other side divergent. You see, A less than or equal to B. B is infinity. Can you say A is infinity? No, because you have to go the other side. Okay, it's not easy. If I change the sign, like n squared minus n minus 1, comparison test may works. Okay. If the comparison test does not work, use the limited comparison test. Okay, no, it's not that easy to use a comparison test. So for some series, limited comparison test is, because you think it's almost like, right, after delete n plus 1, right? Then, yeah, then in that, if you use this method, then you get a simple one, then use a limited comparison test. Don't use a comparison test, okay? Because it's harder for you to prove something in coordinates, right? Yeah. So the comparison, this is the n. N is less than equal to n squared, which is n over n, which is 1. But that does not help. Okay? I know this is a Bn equals 1. I know Bn is divergent, but does not imply An is divergent, right? Because this is including that direction. But you can, yeah, you can simplify in this form, okay? Then the limit of N over Bn is going to be 1, but this series Bn is divergent. It's obvious. Every term is equal to 1, right? So then this implies is divergent by the limited compression test, not the compression test. You have to take the limit, because if you want to prove N is divergent, sigma N divergent, use a compression test, you have to say N greater than or equal to Bn. But that's not true, okay? So unless I change the problem a little bit, then the compression test works, okay? Now, yeah, you can apply, yeah, we can apply the compression test to this series, no problem. This is when N started from maybe from 3, because I need an N square minus, yeah, something like that. It's okay. Okay, N start from 2 is fine, not 1. 1 is 0. Then you can show this is divergent. The reason is this An is greater than, sorry, it's N here. Okay, this N is greater than or equal to N over square N squared. And that is 1, that's a Bn. So right hand side is divergent, implies left hand side divergent. Okay? Yeah. Then you see, then you have this, right? But this side is the infinity, implies the left hand side is the infinity. If N is less than or equal to Bn, then you cannot conclude N is divergent. Sigma N is divergent. Because you only can see that it's less than or equal to infinity. Of course, every number is less than or equal to infinity. Finite to that, infinity doesn't matter. All right, so this is a remark. But for this particular problem, you can use the nth term test. Nobody mentioned that even, right? Nth term test for divergence to prove it's divergent. Because if you go back to this problem, this is what I really want to do that. This is An, but the limit of An is going to be 1. It's not going to be 0. Okay, therefore, this series is divergent by the nth term test for divergence. Okay. Just because this is special. Now, if I change the problem a little bit, I delete the n on the top, I cannot use this nth term test for divergence. Okay, but if I modify this problem to this, then you cannot use the nth term test for divergence, because in this case, the nth term approaches 0, right? So nth term for divergence is useless here, right? But this series is still divergent. To prove that, you have to use the limited compression test. So the limited compression test is best in this case. Yeah. Nth term test This cannot be used here to prove it's divergent. And this is an n, because n is going to be about 1 over n, which is Bn. Bn is divergent, sigma Bn divergent. That implies n divergent. Okay? Okay. So this is a, I know this is divergent. I know that. Divergent by the P-series test. Okay, P is 1. So this implies this is divergent. By the limited comparison test. Okay, limited comparison test means I do have this limit. Okay. Hi, that's a good question. Second problem. I modify a little bit. Okay. Now, if I modify, you see, I just put the negative sign, -1 to the n, n to n minus 1 half, right? It's become alternating series. Is it divergent or convergent? Why? Still divergent? Which test you can use? Don't need to care detail.
You can say that an is still 1 as nf is infinity. But if you want to use it alternating series test, it must be.
So your comments only said that you cannot apply alternating series test.
No,
but that's that's right. But that's not mean that you already proved it's divergent. I am asking which test you use to prove it's divergent. The alternating series test only tell you whether the series is convergent. Right? You cannot use the alternating series test to prove something is divergent. Remember the statement of the alternate series. If such condition holds, then it's convergent, right? Never say anything about when it's divergent. The series does not meet the condition listed in the alternating series. Does not mean the series is divergent. And that's logic. Okay? Because not sufficient necessary condition. Many tests just only one side implies others. Right. Even the ratio test, you get a limit L. Then still that's the case L equals 1, inconclusive. Right? L is greater than when it's convergent and divergent. L is less than when it's convergent. You remember, right? And L equals 1, inconclusive. You cannot jump to any conclusion. No conclusion used. Okay, now I'm asking.
Well, I tried a ratio test and that was inconclusive as well.
Oh yeah, ratio
So-
test. Don't use a ratio test for series like that. If you
Yeah.
don't see like a power function, okay. If you don't see, exponential function or n factorial, something like that, don't use it. ratio test. You get the limit is going to be 1.
Right.
Okay. You still use the nth term test for divergence. The reason is this is the n. Your conclusion is the limit of n does not exist. Okay, that's it. The limit doesn't exist is because the second part converging to 1, but negative 1 to the n minus 1 always keep changing signs. So that's why it does not approach any finite number. So the limit does not exist. Does not exist, of course, it's not going to be 0, of course. Right? So then implies the series is divergent. By the nth term test. Now my trouble is you claim it's divergent. Wrong idea to put in there. And the proof it does not support your claim. It's hard for me to give you partial credits. How much? Okay. Yeah. So make sure you memorize this test correctly, the statement of test. Don't use the wrong test. Okay. All right, this. Convergent dynamic. Okay. So what is your method to prove it's convergent? Huh? What you can see?
The word test.
Insert. Insert. No, road test. Yeah. That's one convergent test. You can use the road test. You can use a ratio test. You can use alternate series test. Okay. 3 tests that you can use. So alternating series test. When you use a ratio test, more likely you can also use a road test. Okay, it is actually a Basuri convergent. If you use the alternating series test, you cannot conclude it's a Basuri convergent. But if you use a ratio test, a road test, you can even get more strong conclusion. Okay, and so this is the end, right? So let's use ratio test. Doesn't matter in this case. Put double suit value symbol here. So don't, and then you forget the negative sign. And then here is n plus 1, 3 to the n plus 1, n over 3 to n. And then you simplify, you will get 1 over 3, n plus 1 over n. So the limit is 1/3, which is less than 1. Okay? Now, there are some students know how to do the problem. The method is correct, but when you simplify it, always make mistakes. The limit is supposed to be 1/3 and get infinity, for example. I'm feeling very sorry about that. But just be careful when you simplify the expression. If you knew already this will be convergent, then don't end up with the limit like infinity. Okay, then you change your mind, change your conclusion. Okay, so therefore the series is absolutely convergent. Okay, now this I have to mark it. This is n, including the negative sign. Absolutely convergent. Good. And I still have a negative sign here. Ooh. All right. This problem with the negative sign or without negative sign, that's the method is quite different. Okay. Without negative sign, this is divergent. Okay. I'm not going to prove that. I just give you a note. So for about that series, okay, it's convergent. You use the alternating series test, okay, and it's condition convergent. So this is your Bn. So Bn is positive, clear. Second, Bn convergent to 0, decreasing. It's not clear. So what I'm going to do is I change it to this form. Bn is actually purified. What you do is you multiply the numerator by that, divide by the same thing, and so the numerator becomes 1. The denominator is square root of n plus 1 and plus n. All right, so this clearly decreasing to 0. Decreasing is clear. The denominator is increasing. And the converging to 0 is also clear. The denominator approaches infinity. So that's it. Then this series is convergent by the alternating series test. Okay. Yeah, let's take a look at it. And start from convergent divergent. Why? Which test are you going to use? Yeah, this is probably the best way to do. Yeah. The reason, yeah, this is n. N is about n over n cubed. This is n squared, which is Bn. Okay, so then you take the limit. because this is how do you get the Bn, so the limit is always equal 1. I just drop some lower order terms. And then we also know that this is a convergent, okay? Why? By the P-series test. And then implies N is convergent. Okay? Okay. The next one. Okay, let's begin with the first one, just N. Okay, this I change 2 to let's do this first. Make it easy. Okay, there's some difference, bigger difference. Yeah, just change it to okay. This is convergent. How do you prove that? Use a root test. Okay, this is the only one. Say it's a root test, which is going to be okay. After simplifying, it's n over n squared plus n. Clearly, the limit is 0 as n approaches infinity. 0 means it's a smaller than 1. Right? So that means yeah. So it's a smaller than 1, right? So that means it is convergent by the root test. But if I change it to the 2n, the numerator, then you have trouble because the limit is only 1. Ratio test does not work. Okay, the ratio test does not work. Yeah, I don't want to give you that problem. The ratio test does not work, yes. So it's inconclusive. All right, let me ask you to do this quick. This is just n. Okay, are you done? Divergent or convergent? Or some students trying to use a ratio test, right? A Lotus test. Okay, the Lotus test, what you get? The Lotus test, after you simplify, it's going to be n squared here, n squared plus n. So the limit is what? Inconclusive. Yeah, inconclusive. So low test does not work. Okay. It's convergent divergence. It is the cutoff line, right? This is always, the problem when you do scientific research. This area always, some discovery, right? It's divergent. The argument is very simple. One sentence. The reason is, if you see, the purpose I turned upside down, right? I just want to make it greater than 1. So this n okay, clearly is greater than or equal to what? Right? So it's never, so the limit, I don't need to know what is limit, but the limit definitely is not going to be 0. Therefore, this series is divergent by the nth term test for divergent. Realize that it's not easy to be lawyer. Okay? Sometimes scientists, they're not smart guys. They have to be really, there are lots of written rules. They have to find the right way to argue he's not guilty or he's guilty. It's not easy yet. Okay, you have to have good memory, as I'm pretty sure, and then also have quickly search for those rules. But in the future, I think we can use a computer to do that, because all the laws sent with everything in the computer. The computer can be very smart enough for you to collect all the information quick, present it according to which, and this is good or bad. That's my opinion, okay? And actually this is so when you choose a major, you are thinking about, is this your job will be replaced by computers, by machine in the future, okay? All right, so now we are going to do some other problems. Okay, power series. A typical problem is this one. So f of x is going to be, I just randomly write down the problem, 3x plus 1. Okay, find the power series representation for this function. At where? At a equals any number, right? As long as not making the denominator 0, right? I can say 2 or 3, 4, 5, doesn't matter, okay? I just let's say that's 2. Okay, so your power series representation will be like x minus 2 to the power n, right? How to do that? You have to use the following fact. This is a fact, okay? It is going to be, sorry. The fact is, if you get 1 minus something like u, right? Then this should be equal to, and for absolute u less than 1. This is identity. And we're going to use this to get the other one. So x minus 2, I'm going to let you like it. I'm going to use any number. Okay, I can use x, y, z, w, doesn't matter. Let's w to be x minus 2, right? Then x is going to be w plus 2. Then the function of it is going to 2 and 3, w plus 2 and plus 1. So after simplified, I got 3w, 6 plus 1, 7. But this does not look like what I got, 1, right? It's okay. I take 7 out. So what I got is 3w over 7. That's very close to that. But it's plus, not minus. Well, I can make it minus, okay? 1 minus negative 3w over 7. Then this is my u. Okay, I can expand it. Negative 3w over 7 to the power n. And this holds if this is less than 1. Right? So let's simplify it. I got alternating series. That's okay. Then I have a 2. I have a 3 to the power n. And I have a 7 to the power n. N plus 1 actually. Here's w to the power n. And w should be less than 7 over 3. So also get a Rayleigh's convergence. Okay. Okay, the answer is very simple. X minus 2 to the power n, and here x minus 2 to the. So when x is close to 2, and you have decided that the given function like a natural log of x, okay, I want to, this is defined for x greater than 0. So I find the Taylor series at any number. A could be any number greater than 0, it's fine, right? Because the function is defined for positive x. So at a equals 1, 2, 3, 4, 5, and really doesn't matter. So I can say 10. I just randomly pick as a number. Okay. So what I want to do is I want to make sure natural log x is going to be something like that. Okay. And that clearly x minus 10 should be less than 10. The reason is I can guarantee x is greater than 0. Okay. So this is actually is going to be like an interval from 0 to 20, right? Because x cannot be smaller than 0. Otherwise, natural log of x is not 5. All right, so that's what I want to do. I have to recall the formula. 1 minus u is going to be negative and u to the nth power. Okay, I need that, and absolute u is less than 1. This is a fact I need to use. All right. This comes from the power series representation for 1 over 1 minus u. Okay. All right. So now I'm going to modify. I have to let w to be x minus 10. So x is going to be w plus 10. So the function is going to be natural log x is going to be w plus 10. All right, w plus 10 is quite different from 1 minus u, but I can make it. Okay, I can make it. Natural log of 10 times 1 plus w over 10, right? So I can get natural log of 10 plus natural log of w over 10. So it's very close to natural log 1 minus u. And here's a plus w over 10. So I still have to change the sign. 1 minus negative w over 10, right? And this is my u. And then you apply the above formula. And here, negative w over 10 to the power n. And here, you have this in code. Okay, w is x minus 10, remember. Okay, so now I have negative 1 to the power n divided by n. And here I have a 10 to the nth power. And this is a w to the power n, so x minus 10 to the n. And here x minus 10 less than 10. Okay, so we get the answer. This is what we got is a power series representation, but you can say that this is just a Taylor series. Okay, it must be the Taylor series. Okay, that so you don't need to find the derivatives, and you evaluate. Don't use the definition for the Taylor series to solve the problem. At the end, I want to go back to this, look at this problem. That is going to be n to the n plus 1, n plus 3, for example, to the power n. All right, let's go back. How do you know this is a convergent or this is divergent? This is my last. This is the most difficult problem. If I have to put it on the final exam, this will be the bonus problem. Okay, why? Because you cannot use the typical method. Sure. You cannot load test, definitely try. Load test, this is n, right? And after you simplify it, you will get n over n plus 3. So the limit is 1. So the load test does not work here. Then what? It's divergent. Anyway. I think it's that. So the load test does not work. I'm going to use in the following fact. Okay, the limit, this is a well-known formula, right? Right? We're supposed to know that. That's E. Using this fact, I get, okay, more general, okay, 1 plus n with r to the nth power, right? When we calculate the interest rate, yeah, okay, so this is going to be 1 plus n r, here's r to the n, then r, so the limit is e to the r, okay? As n approaches infinity, because inside this approaches. All right, so that means, go back to my n. My n is n to the n plus 3 to the power n, right? So I can write the following. Okay, then I got, if I express in that form, you know it's clear, right? Okay, so the limit, it has limit. It's not going to be 0. It's going to be e cubed. It's not going to be 0. So the nth term does not approach 0. That's why it's divergent. Okay, so that means, yeah. So this series is divergent by the nth term test. For divergent. So the reason I want to say the nth term test for divergent, because nth term test never can be used to prove it's convergent. Although the nth term convergent to 1 over e cubed, but as long as it's not converging to 0, then the series is going to be divergent. So the reason is, when n sufficient large, the term is almost equal to 1. Every term is almost equal to 1 over e cubed. But 1 over e cubed is a positive number. If you add 1 by 1, and if you add 1 million, right, 1 billion of such number, the number is getting larger, 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 right? So that's why it's divergent. Okay. But this formula, yeah, it's really coming from, see, the number e come from the finance. Okay, it's like pi, you know, human being introduced pay attention to 2 special numbers. One is pi, other one is e. Okay, so if you, yeah, just call, you know, just let you know that if you have initial deposit, yeah, if you have initial deposit, and the I is the interest rate, right? Annual interest rate. Then if the interest is compound n times per year, okay? If interest is compound n times a year, so if you put the money into the bank, so in T years, okay, the balance is going to be E times R to the N, and this is going to be NT, right? So if it's compound continuously, that means you divide the whole year into seconds, or even the computer can do that every second, right? So that means in sufficient large, but the interest rate is fixed. That's the reason the limit is going to be e to the RT. Okay, that is the formula people use if the interest is compound continuous. I did a calculation if the annual interest rate is 8%, okay, 8%, how many years the money in the bank will be doubled? It's not in the bank. Sometimes I have to do it. Portfolio. About 8.7 years. So if you deposit $1,000 in some account, some portfolio, some mutual fund, if you're sure the return rate is about 8%, then 8.7 years later, use this formula, the money will be doubled. Okay, and everyone who eventually get a job and make money should learn how to invest the money, because it's very important. Even your co-workers make $10,000 more, even $20,000 more per year from you, and you both have the same financial burden, for example. If you know how to invest the money, and 10 years later, you'll be very wealthy, and the other guys still on lots of loans. Okay, so but you have to understand those mathematical formulas. That's my own. Okay. I finished the review for the second test. I wish you to go through all my lecture notes and including the review card. Okay,